Hello and welcome to this video about Python sets for data handling. In this video you will learn about the Python set, which is a Python native data storage abstraction, or you could say a native Python data structure. The set provides you with the option to economically store unique labels or objects. These labels or objects will be fixed and are not intended to be changed while the objects are contained within the set. Sets have two main uses within data handling. One as a storage type for unique labels or objects, making the data storage requirements smaller for certain data storage systems. The other use is within algorithms that operate on, for example, data forms with unknown but unique properties, such as unique column or row labels in a spreadsheet. Then the set is a useful holder for column or row labels, or you could say object identities or names. Python's native set class has developed a lot over new Python versions, and more development is expected in the future. So let's take a more detailed look at the set. And the set is a Python data storage type for an unordered collection of unique objects that cannot be changed as long as the object is within the set. This means that set is a collection of unique objects and that it contains objects that can only be one of a kind, and that the stored objects cannot be changed as long as they are contained inside the set. The properties of sets are that sets are mutable, and that is that new elements can be added after the set has been created or defined. So this means that you can increase the size of the set and add new items to the set whenever you want. There is one exception to this, and that is that the set can be made immutable through Python's frozen set function. And that means that the set will be effectively frozen and cannot be changed after the use of Python's frozen set function. Sets are unordered and don't have index numbers inside the set. And this means that there is no function to sort the set's contents using the set itself, and that there is no formalized index function included with the set. The order of the contents inside a set may therefore appear as being random or arbitrary without being either random or arbitrary. Python sets allow for math operations such as the union, intersection, difference, and symmetric difference between two or more Python sets. And this means that it is possible to compute union, intersection, difference, and symmetric differences between two or several Python sets. And this property can be used as one of the many ways to find duplicate objects or similar uses of these math operations. So, the main use of Python set equivalents in older administrative data science code was to economically store labels connected to integer codes. The stored set codes was mainly geographical localities or telephone numbers, postal area codes, state codes, localities, or whatever type of codes you or anyone wanted to use. And this made similar constructions to Python sets very useful in the early era of computing, when RAM memory and storage space was expensive and very constrained, whereas current application storage space often, but not always, grows faster than the need for storage space, for example in cloud computing. At the most basic design level, this design resulted in that 8, 16, or 32-bit integers could replace a string or a number of strings for a data entry. And this was very economical. Currently, however, coders often store entire strings in each data entry, which creates a lot of data handling work due to many different strings representing the same object type, or completely unique string entries may be created, such as, for example, a non-existing unique street address that the post will be delivered to without complaint due to the human capacity of converting the non-existing address to an existing address. Another modern option is the year 2K dictionary object, which can do the same trick by using the integer as a key and the string as a value, while not needing any lookup code attached between the key and the value. The modern dictionary could thus be viewed as a double set or as a set plus a list for every set entry, although it is alleged that Python sets in some versions of Python are implemented using dictionaries. So, Python sets are used in some data science and machine learning algorithms where sets may be used as containers for column or row identities. So you can have sets which are unprocessed and sets or other storage abstractions which are processed. And when an object has been processed, you move it from the unprocessed set into the processed set or other storage abstractions. Similarly, you can have a set of features or columns or rows can be included in the model, and they can be excluded from the model. The columns, features, observations, entries, or rows can be struck from being included in the model or investigated to be included in the model. The math operations that Python currently allows on Python sets can be used to further extend this type of use of Python sets. All right, let's talk a little about how Python creates a set. And Python creates a set by using the curly brackets enclosing objects or items within the set. And another way of creating a set is by using the set constructor. So right, now we're going to make a number of coding examples to show some of the Python set's properties. So start up your code editors because we're going to type some code. All right, having started our code editors, we will start to type some code. And we will begin by describing the code we will type. So we type Python set. And we will start by creating a set named fruits with string fruits objects inside the set. So we type create a set named fruits with named fruit objects strings inside the set. And we will use the curly brackets, and we will use strings as fruit objects. And we will close the curly brackets, and we will print the fruits. And we can print the type of the fruits. So let's run this code. And as you can see, the Python set only accepts unique objects. So here we can see that we have 2 bananas, and 1 banana disappeared because Python doesn't accept duplicates in a set. And similar with the apple. So let's type all duplicates of fruits were automatically removed from the set, and only one instance of each fruit object remains. And we can type the objects appear to be random or unordered, but are they random? And we can test this by simply cut and pasting this code. We create a new set of fruits. And what is of interest is this order here. Or you could say this unordered collection of string fruit objects. So let's run this code. And we can conclude that the Python set is unordered, but not random. There is an order to the set under the hood. So all right, now we have shown that the set is unordered, but not random. So now we know that there is an order under the hood, but we cannot see what type of order is implemented currently. And this means that we have to accept that the set is unordered. So all right, let's test some set functions. So let's test to add more fruits to the fruit set with the add function. So we can type add more fruits to the fruit set with the add function. So we type fruits, add a lemon, and we type fruits, add a banana. And we can print the fruits. And this will show that duplicates are removed and that new items are, you could say, added. So here we will display the mutable concept of the set. So let's run this code. And here we can see that the banana was removed as it was already included in the set. But the lemon was added because there was no lemon inside the set. And we can try to add multiple items or objects to a set using the update function. So we type add multiple objects or items to a set with the update function. Or you could say method. So we type fruits, update, and now we can use a list of fruits. So we have a pear, we have a citrus, and we have a peach. And we close the list like this. And we type print fruits. So let's run this code. So here we can see that the pear was added, that the citrus was added, but we already have a peach in this set. So the peach was not added but removed. So we can type the new fruits were added and the duplicates were removed. And now we'll try to copy the set. So we type sets can be copied using the copy function. So we type fruitage equals fruits dot copy. And this will create a shallow copy. So we will print fruitage So let's run this code. And we have a copy of the fruit set, and that copy is named fruitage. And now we'll remove objects from the set using the remove function, and we will test the fruitage copy a little. So let's type remove objects from a set using the remove function. Or you could say method. So we type fruitage remove, and we can remove the citrus. So print fruitage and we print test fruits. So here we just print a string and we print the fruits. So let's run this code. And we can conclude that citrus was indeed removed. And we can type that a shallow copy is sufficient for this use. And if it is not, then the alternative is a deep copy. So let's try various ways to reset, clear, or delete a set. So we will clear a set from its object using the clear function. Or you could say method. So we type fruits, clear, and we print the fruits. So let's run this code. And we can see that the fruits set is empty. So here we have a set which is empty. So let's test to delete a set with the delete function. So we type delete a set with the delete function. So we type delete fruits, and we will print the fruits. And we can say that this code will throw an error if fruits have been deleted. So let's run this code. And here we can see that the set is indeed deleted, and this error proves that there is no set or object named fruits. And now we'll loop through the fruitage set. So let's type loop through a set using a for loop and print the contents. So we type for fruits in fruitage, print fruits. And let's run this code. And here we can see that the set is iterable and that we can loop through its contents. And now we'll test some set math operations and show the current way to move an object inside a set into another set. So let's type create an empty basket set and put some fruits in it using set math operations and a mover set. So we begin by creating a mover set like this, and we add an apple to it. We can add a peach, and we can add a banana. And we close the set, and we print the fruitage to display the content of the fruitage set. And we type basket equals mover set intersection with fruitage. And we type fruitage difference update basket. And we can type that future Python sets may have a one-liner method for moving an object between two sets. And we will print the basket and we will print the fruitage. And we make a little change there. So let's run this code. So here we can see the original fruitage set, and here we can see the new basket set. And we can see the resulting fruitage set after we have moved the peach, the apple, and the banana into the basket set. So this is what we can see from this code. The apple, peach, and the banana was moved from the fruitage set to the basket set with a mat operation method. And this method has the advantage that it works with most objects and not just basic strings, ints, and floats. So even if you have your own designed, you could say giraffe or elephant or donkey object, and you have put it into a set, this set mat operation will work. Whereas some other methods may be constrained to Python native types. And as we stated or typed, in the future, a more proper move object method will likely be designed because this set has been developed at ultra speed since Python 1 and 2, and we expect this development to continue. So right, in this video you learned a lot about sets and how sets can be used for data handling. In the next video we will teach you more, and we look forward to see you in the next video.